All right, let's get started. All right, good evening, everyone, and welcome to our September meetup. My name is Damien, and I'll be your host for tonight. Also with me is Himansu Patel, who is going to help with coordinating the meetings. And then we have our two guests. We have Oleg and Michaela from Kubler. So that will be the main presenters. But for tonight, we actually have two presentations. I will start off with the presentations, and then after that, I will, pass the microphone on to Oleg, who will continue with the presentation. All right, so I hope everyone is doing good. I hope you are keeping safe. So as usual, let's introduce the meetup, and then I will start my own presentation. Today, we don't have Brent. Brent is away, and Brent is one of the organizers. But we have Himansu here, like I said, and my name is Damien, and then we have two guests from Kubler. All right, so about CTE, Cloud Technology Experts, we're mostly into training. We do Kubernetes training, we do AWS training as well. We're mostly into boot camps that get people the opportunity to find the job of their dream. So that is what we've been doing now for like 3 years. And if you need any of those services, of course, we're here. All right, so some announcements. We always need people to help with the meetup. So if you have some time to spare, please always let us know. If you want to speak, if you have something to share with the group, also please do let me know. Then the next meetup is going to be for October 21, and it will either be online or both online and in the face-to-face as we used to have it. Okay, so that is just about the meetup. And in my presentation, I will talk more about the things that I would like you to know about microservices and why the meetup actually exists. So the title of my talk is called The Rise of Microservices. Please permit me, I'm not going to make it in full presentation mode, just because when I do that, certain things happen here which I'm not going to be able to fix before we get on with the meeting. All right, so the rise of microservices. So in this meetup, every now and then, when we have the meetups, we get new people coming in, people joining in for the first time. And most of the time, first time also means that they are completely new to microservices world, Docker, Kubernetes, and all that. So what I try to do is to try to bring everybody kind of like on the same page, up to speed in a few minutes, so that when Oleg starts to present, at least you will know what he's talking about. Without that, it's usually difficult. So take my presentation to be kind of introductory to get you up to speed with the world of microservices. And then along the line, we'll also know why we're doing this meetup. All right, so again, my name is Damien. I have several certifications, including CKA, which is the Certified Kubernetes Administrator. And I love running. I try to do one marathon each year. And if you want to reach me, that is my email over there. So this is the agenda for my presentation. I'm going to start off with a quote from someone called Mark Anderson. And then I'll move on to talk about the things that I think you have to be aware in the modern IT infrastructure platforms. And then I'll talk about the rise of microservices, then talk about Docker and Kubernetes, how they help us in these infrastructures that we are talking about. Then we'll see how Kubernetes helps us to deploy our microservices application. And then after that, I'll talk about the architecture of Kubernetes. I might create a simple microservice for you guys on Kubernetes. And then after that, I will conclude. Again, this is meant to be a short presentation. I don't expect it to last more than 30 minutes to 40 in the maximum, except there are questions. Okay, so to start with, there's a guy called Mark Anderson who said that software is eating the world. Software is eating the world. I love this quotation. I've used it so many times because I think it's so true. He made that quote about, I would say, 12 years ago. Mark Anderson is an entrepreneur. He is the founder of some of major IT corporations today. And that was his quote 12 years ago. Now, if I may ask you, on the screen, you can see a lot of companies that I put here, Google, Facebook, Twitter, LinkedIn, Uber, Lyft, on and on. What do you think is common to all these software companies that I have here? What can you identify as a common trend or a unifying trend for all these companies? All right, maybe even if you say something, I may not, hear you, but software is what, connects, is a commonality among all these corporations that we have here. All these corporations I have here on the slide, they pretty much present software to us in one way or the other. And so you can see how software is becoming a big part of the IT infrastructure or the overall business world in today's economy. All right, so that is what Mark Andreessen meant when he said more than, let's say, 12 years ago that software is eating the world. He is saying that software is becoming really, really relevant in our world, both for IT corporations and also for non-IT corporations, even traditional companies like Walmart. They are now into software because as Walmart, for example, continues to compete, if it doesn't have a good web presence where people can order stuff online, maybe with time, they may not be that relevant. All right, so when he made that statement several years ago, companies like Uber and Lyft were not even in existence. Now we have Uber, we have Lyft, we have Airbnb, which I don't even have here. So in fact, the list is just too many to list. Even LinkedIn is not here yet. Now, I don't know if you've heard of Snowflake. Snowflake is a company that maybe today the IPO have started. I didn't read the news, but I know that it was making a lot of news that, Snowflake was going to make a big news. People want to buy the shares of Snowflake because they think it's going to be like the Oracle of the past. All right. So, and, it's still a pure software company, as you can see here. All right. So I hope I've made my point. Software is becoming really, really important in today's IT or in today's business. Then I'll move to the next thing, which is the cloud. Several years ago, a lot of companies were still a little bit skeptical of the cloud. They were not sure if it's a platform for them. They were not sure if the security is good enough. They were not sure if they want to hand over their data to a third-party organization. But today, the cloud is a new normal. This is what AWS used to say. The cloud is a new normal. And in fact, every year, as you may know, the revenue of AWS doubles, all right? It doubles because more and more people are beginning to move to the cloud. And so we can see that the cloud is the platform of the present and the future. And not just the cloud, there are also different ways that people are leveraging the cloud. Some people have what we call the hybrid architecture, where they still maintain their own on-premise infrastructure, and then they connect to the cloud. Some still are using multiple cloud environments. They are using AWS plus Google Cloud plus Azure all at the same time. They want to leverage the best of the best when it comes to the services that they are trying to utilize. So if they think that maybe AWS is better for compute, then they'll be using AWS for compute. If they feel Azure is better for data analytics, they're going to use Azure for data analytics and stuff like that. So multi-cloud is becoming more and more important as well. And linked to that is the company I mentioned earlier, which is Snowflake. Snowflake, what makes Snowflake so relevant is the fact that you can use it across any cloud. You can use it on Azure, you can use it on AWS, you can use it on Google Cloud, on and on. So those kind of infrastructures that help us to share our environment across different cloud platforms, these are going to be also the future. Now we're seeing a lot of trend in that direction. All right, so that's my second point. First, we understood how relevant the cloud is, the software is. Then we understood also how relevant the cloud is, how the future is a cloud. Then my third point is on applications, all right? On applications, when people begin to move the applications from on-prem to the cloud, they discover that applications, they just move from on-prem to the cloud, they don't scale. Now, the reason they don't scale is primarily because the architecture of applications when they're deployed on-prem are different from when they are deployed in the cloud. And a lot of corporations, when they started migrating the applications to the cloud, they had to discover this when they started. And one of the first companies to make this discovery was Netflix. I believe most of us here watch this Netflix. Netflix was running on-prem, so they decided to move to AWS. When they moved to AWS, they discovered that, well, the application wasn't going to scale at all. So they had to do something about it. So in doing something about it, they gave the name microservices. Okay, I'm not sure if they were the one that coined the name, but now the applications architectures in the cloud are called microservices, while the application architectures in on-prem are called monoliths. Now, if you see how the on-prem infrastructures look like, typically you have a single box, a big box, okay? And then you deploy your application on that box. When you need to scale, you can scale up, what we call vertical scaling. You may add more resources to give you more capacity for the application to work. But when you move the application to the cloud is designed to be horizontally scalable. You are not so much interested in vertical scaling for several reasons. First of all, when you have vertical scaling, you cannot have 24/7 application because sometimes you need to bring down the server either for upgrade or for maintenance or for one reason or the other. When you do that, your application will be offline. So in the cloud, you're going to do horizontal scaling so that when you're working on one, if there's a need to work on one, all the other components or all the other microservices are still running in the cloud. Okay, so from vertical scaling to horizontal scaling, that I would say that is the primary reason why applications moving from on-prem to the cloud have to be redesigned. Also, if you look at things like CI/CD pipelines that are common in today's DevOps environment, monoliths are very difficult to be able to do continuous integration and continuous deployment. But when you break down the application and then you split it into several components, it makes your life easier in terms of how you manage this application. So essentially, let me see if I can just draw something quickly since I don't have the slide to illustrate to you how a monolith is different from a microservice. So once I show you that quickly, then we'll see the problems that we actually have with the microservices architectures, and then we'll see how Kubernetes helps us to solve the problems. Okay, so I'm going to come back here and then look from application quickly. Okay. So I'm going to call up the application. All right, so if you don't mind my drawing, I'm just going to draw a big circle, and I'm going to call that our monolith. This is a monolith architecture, because if this were on-prem, then this would be deployed on a server, monolith. All right. In the microservices architecture, we're going to split this application into several components. Let's just split it into three. Now we have A, B, and C. Now, in the microservices architecture, we're going to have three applications or three microservices, A, B, and C. In other words, each one of these becomes a separate application here. All right. So when they become separate applications, these are all autonomous. They are all independent of each other. Autonomous. All right. Again, so now once you have this microservices application, the normal way to deploy these applications is to send each one of these to a Docker container. And again, if you're hearing the word Docker container for the first time, let me increase this. That will make it easier. So now you send each one of these to a Docker container. This one will go to a Docker container as well, Docker. And each one of these will go to a Docker container, where first of all, you create the image, okay? You create the image, and then from the image, you create a container. So typically, that is how you're going to deploy this architecture, but I'll talk a little bit more about it in a moment. So now we've managed to split this monolith into a microservice, which means now we have several components of the same application that need to coordinate to do the job that this monolith was doing. In that case, it's easier for me to scale this independently of this one, scale this independent of this one, and then I can have my microservice application running across different containers, different Docker containers. Okay, so from a single application to a distributed application. Now, essentially, this is a distributed application, right? Distributed application by their nature are always kind of difficult to deal with. I know we're trying to solve a problem here to make this application run very well in the cloud, but in the process of doing that, we end up with a distributed application, and distributed applications are difficult, okay? So we're running into other issues. Now, some of the issues we have to manage in this environment are going to be things like communication. Let me write them here because those will be easier. Let me go back to the slide. Okay. All right, so some of the issues we're going to deal with in that distributed architecture, we're going to deal with scheduling. For example, how do we send one microservice to the node where it needs to run? Because in a Kubernetes environment, for example, we talk about clusters. When you have those clusters, how do you schedule a pod or a container from to a particular node to run on that node? So that is one issue we have to deal with. Another issue we have to deal with is how does one microservice A talk to microservice B? How does it even know that microservice B is there? That is one issue we have to deal with. Then load balancing. I just told you about doing horizontal scaling. When you do horizontal scaling, it's possible for you to end up with, let's say, several replicas of the same application running at the same time, maybe 30, maybe 100 replicas of the same application. So when people need to access that microservice, those different replicas that are running on the system, you need to have a way of directing traffic to all those endpoints, okay? And you want your load balancer to solve that problem for you. So we have to also deal with the issue of load balancing. Service discovery is how does service A find service B? And load balancing is in the case where we have all these replicas running, how do we effectively direct traffic to our multiple replicas, all right? Then we have to deal with monitoring because this environment is going to be complex. So you need to know what is going on. You need to have some visibility into your own environment. You need to deal with logging so that if you want to troubleshoot, you'll be able to deal with troubleshooting. And remember, you're dealing with so many of these microservices, so you need to have an effective logging mechanism, probably a centralized way to see all the logs from all the containers or the microservices running on different nodes. Then, most importantly, we need to handle communication. Now, microservice A may need to talk to microservice B, B may need to talk to C, on and on. You need to handle that. Security, how do we ensure that this environment is properly secure? And part of what Oleg will be talking about is going to be in the area of security. And storage, how do we provide effective storage for each one of these microservices that is running? And also networking, which is kind of linked to communication. How do we ensure that these microservices are able to effectively communicate with each other? So these are just some of the problems to make you aware of the complexities that exist in a distributed environment with our microservices that I just told you about. So one of the companies that started this move I mentioned earlier was Netflix. Netflix started this and then they experienced a lot of issues, okay? But they have to solve the problems, right? In IT, that's what we do. We encounter problems, we solve them, and then we achieve our objective. So Netflix has to go through a lot of learning to solve all these problems that we talk about here. And fair enough, they open source most of the libraries like Eureka, which helps with service discovery and stuff like that. But it was still difficult, and also it was based mostly on Java. So if you're not writing your microservices on Java, then good luck. You still have to go and try to do most of the things that the problems that Netflix was trying to solve. Okay, so I would say around that time, or let's say fast forward until somewhere around 2015, then Kubernetes was becoming to make waves. All right, I think around 2014, Kubernetes, Google decided to open source their orchestrator that they have in-house that they were using to manage all the applications. And then they decided to make it freely available. At that point, There were also some other competitors like Docker Swarm was realizing these problems, and Docker realized this problem and they came up with Docker Swarm, and a bunch of other ones like Nomad and all that. But to cut a long story short, Kubernetes proved that it can do the job. It proves that it's the best of the best, and so people adopted Kubernetes. And so around that 2015, I believe that was when the CNCF, Cloud Native Computing Foundation, was initiated, which is a body that I have here for you to see, called the CNCF. Okay, so CNCF is the body that is responsible for managing cncf.io, that is responsible for managing Kubernetes. Okay, and so Kubernetes became open source, and then they formed this body, CNCF, to oversee that Kubernetes was in good hands. So Google partnered with, I would say, Linux Foundation, and then they established this body called the CNCF, which is going to cater for everything cloud native. If you wanted to build your applications in the cloud, you have a body that is responsible for giving you guidelines, directions on how to go about doing it. Okay, so as I was saying, the main advantage of Kubernetes was that you don't have to write your application in any language. You don't have to have it in Java or Python or whatever. Kubernetes will take any language, okay, because it works with Docker, and Docker doesn't care which language you use. So long as you can package your application into a Docker image and use a Docker container to run that, your image into a container, then Kubernetes really doesn't care which language you use. At the same time, Kubernetes was able to solve all these problems that we have here. Kubernetes was able to solve all these problems, which means when you're working with Kubernetes, when you have your microservices deployed on top of Kubernetes, it makes it easy for you to do everything that I put down here. The beauty of this is that the developer doesn't really have to concern himself or herself with solving these issues. Just give this to the Kubernetes, and Kubernetes will help you solve all the issues that I put here for you to see. So as you may see, Kubernetes becomes very relevant because it solves the problems that a lot of people were trying to solve when it comes to creating their own microservices. And like I said, as you can see, software is very important. The cloud is the future. Everybody wants to migrate applications from on-prem to the cloud. As they are doing that, Kubernetes helps them to achieve this objective to make their life very easy. So why wouldn't people love it? And then also, I told you about the pattern where people are using multi-cloud. Because Kubernetes and Docker are actually platform independent. You can use them on any platform, since that is how Docker works. Docker doesn't care which platform you run. So you can move your application from your laptop to on-prem to AWS to Google Cloud to Azure. It doesn't care. So long as you have your Docker engine running on those platforms, Kubernetes is happy to do the job. So I'm talking about portability, ability to port your application from one environment to another environment, which is what multi-cloud is all about. So you can see some of these advantages I'm highlighting. So Docker and Kubernetes came to solve this problem in such a way that it makes life so cool, so nice, so relevant for today's infrastructure that we build. And so you can see why Docker and Kubernetes are so important. And so when we started this meetup in 2017 when CNCF, was now, everyone decided that Kubernetes was going to be the way to go. All the cloud platforms adopted Kubernetes, and so there is no cloud platform that you can go that you don't have Kubernetes deployed on it. Okay, so all the problems I'm talking about, if you come here to the landscape, to the CNCF landscape, you will see that most of those problems I tried to list there, which is not complete. We have this ecosystem here that CNCF present called the landscape, CNCF landscape.cncf.io. You can call it the CNCF landscape. Basically, the landscape gives you the options of all the software that you have in solving each category of those problems that I mentioned earlier, and then they try to tell you which of them is the best. So in each category, for example, in scheduling here, you see that you have all the options I was trying to mention, like Apache Mesos. Then you have the Docker Swarm, but Kubernetes is the best of the best, so Kubernetes is the one that's adopted. Okay, so if you go back again, you see that, I think I should click on this one. If you go back again to another category, you see that they have the answer for you. All right, so not to dwell too much on this, you can always check this up on your own time. But the point I'm trying to make here is helping you to understand why Kubernetes is so relevant in our today's infrastructures. So if we had to define Kubernetes, how then do we define it? Well, Kubernetes is open source. Okay, as all of you know, you can say it's an open source software. It was open source by Google, and if Google uses Kubernetes to manage its vast infrastructure all over the world with Kubernetes, then it pretty much can do the job for anyone. So basically, it's an open source application which can get anywhere, but the main purpose is helping us to deploy, then to scale, and to manage our containerized workloads, i.e. microservices. The definition, I like this definition because it's tied to containerize. So if you don't have a containerized environment, pretty much Kubernetes may not be able to help you. And that is why Kubernetes on its own is not that relevant except you have a containerized environment like Docker. So learning Kubernetes means that you need to have some knowledge of Docker, maybe not detailed knowledge, because Kubernetes will help you orchestrate, to help you to talk to Docker and do everything that Docker needs to do. So you sit on top of Docker with Kubernetes, and then Kubernetes will help you do and manage all the problems and more that I mentioned earlier. So I hope that helps us know why Kubernetes is so relevant. It's all tied to microservices. The fact that people are migrating the applications from on-prem to the cloud, and the fact that they have to redesign these architectures into a microservices architecture. The fact that the microservices architecture were very difficult to implement, but Kubernetes makes life very easy. That is where Kubernetes fits in perfectly. Okay. So I said my presentation will not be long. I'll just run you briefly through the architecture, again, just for the sake of those who are new, and then I'm going to try to round up my presentation. So now that we understand what Kubernetes is, we can look at the architecture. When we talk about Kubernetes, we also have to talk about what we call Kubernetes cluster, because when you deploy your Kubernetes, you are going to need to have a lot of computers to coordinate the running of your workload, i.e. your microservices application. And when you do that, we divide it mainly into two components. We have the plane. We have the control plane, and then we have the data plane. On the control plane, we need to have certain services running, for example, Kube Controller Manager, and then we need to have Kube API Server. We have to have the Kube Scheduler, and we have to have a key value store like etcd database to be installed. Okay, so in a nutshell, your Kube API server is the one that you're going to be interacting with. Every user has to interact. Every user talking to Kubernetes has to talk to the Kube API server. And then when you need to schedule your pods, okay, your workload, your microservices onto the different cluster nodes, then you need the scheduler to help you implement that. And the way Kubernetes works is that it can help you take care of, certain things like when some of your microservices are down, it can help you resurrect them. It can help you bring them back to life, or it can create additional ones to help with the application so that you don't have a downtime. And for all those kind of activities, you can use something called the Kube Controller Manager to help with those objects. Okay, and then all your information gets stored right here on etcd server. That is kind of a nutshell of the control plane. On the data plane, this is where your workload is actually going to run. Your microservices are going to be running here. Okay, in the case where we have 3 microservices, like the illustration I did earlier, you can have one microservice on this node, another microservice here, another microservice here. Or you can decide to have 2 here, 1 here, and this is empty for now. So basically, this is where your workloads are going to run. And on each of the node, we have something called a kubelet, okay, which talks directly with the Kube API server to coordinate every activity happening on your worker node. And then we have the kube proxy, which is going to help with all the IP table and traffic forwarding on each one of the nodes. Okay, I was talking about load balance in load balancing earlier. Kubernetes uses something called the service object to coordinate with other, and kube proxy works with the service object to make sure that your traffic flows the right way. Okay, and then we don't have Docker. Docker is not shown on the screen here, but eventually or essentially you need to have Docker on every node as well. Docker here, Docker here, Docker here. All right, so that is what the architecture looks like in a nutshell. And I have a cluster here just to show you briefly. Here's my local cluster, which I work with. And if I say kubectl get nodes, so you interact with the Kubernetes from the CLI using this command called kubectl. Everything you do with that kubectl, if it's from the CLI. If it's from the management console, I also have the management console here that you can see. This is the Kubernetes management console. Let me try to log in again. So you can manage everything from the console. Let me make it bigger. You can manage everything from the console, or you can manage everything from your CLI like you have them here. Anything you create here will appear, of course, on the dashboard. Okay, so here we have one master, and then we have 4 nodes. But in the 4 nodes, one of them is not ready, so we have 3 nodes that are running. And so that is what your cluster looks like I showed in the architecture there. So let me create a simple microservice, call it up, then I think now you can understand what Oleg will be talking about. So on this node, I have an application here, which I'm going to deploy, which I can quickly deploy for you. Let me see what name it is. Example, okay. I used this one the last time. Example voting app. So I'm going to change to, all right, so let me clear the screen. And I'm just going to say kubectl create -f. So I use kubectl to create this microservice. Okay, it's saying that they already exist. So let me say kubectl get pods -n vote. All right, pretty much most of them are running, so I don't have to run it anymore. I just have to try and call up the application for you to see. Kubectl get SVC. All right, so I'm going to use the service object to call up the microservice application that is running here. So let's call up the vote microservice. So here's a microservice consisting of 4 microservices. Okay, DB microservice, Redis microservice, result, and vote. So, but I want to call the vote because this application is a voting app. It's like an application you can use to vote for the presidential election that is coming up. All right, so we're going to call this application and we're going to call it on that port. So I'm going to go here to my dashboard. Let me use the same dashboard as this one here. And I can put 192. The IP address of my server is there already. And then I'm going to put that there. And then you should see the microservice. Okay, so that is the microservice application. You can vote for Java or for .NET. If you're a fan of Java, you just vote for Java or .NET. You can replace this with your presidential candidates. Very simple microservice, which is running on Kubernetes. So as you can see here, Kubernetes is just helping you to manage your microservices. To create them is very easy. To scale any of these components is very easy because that is what Kubernetes was designed to help you to achieve. Okay, so hopefully that kind of bring everybody up to speed, even though it's pretty fast. But most of these things I talk about here, I have them written in a blog, and some of them I have videos as well. So if you want to go back and listen to them or read a blog, you can feel free to do that. I always tell people, you have to learn Kubernetes. Somehow you need to learn it. It doesn't matter what you're doing. In my own opinion, in the future, Kubernetes will be like Linux. Now people already call it the operating system of the cloud. So if Kubernetes is the operating system of the cloud, I think is as relevant as Linux. So whatever you're doing, maybe time to start to ramp up your speed, one step at a time, take it step by step and continue to absorb the skills that are needed to learn how to manage a Kubernetes environment. All right, so pretty much in a nutshell, I'm just going to summarize and then allow Oleg to do the main presentation. So hopefully we know that what Kubernetes is. It is an open source application that you can use for deploying, managing, scaling your microservices. It's very relevant because people are moving from on-prem to the cloud. And as they move, they need to redesign the applications. And as they redesign the applications to microservices, the platform that can help you manage this in such a way that life is easy, moving from one cloud to another cloud is easy, is just Docker and Kubernetes for now. Maybe something might come up in the future, but for now, this is the platform that is working perfectly, and that is why there's so much trend around Kubernetes at the moment. Okay, so let's see if there's any question. If there's any question, then we can answer them. Otherwise, I'm going to, pass you on to Oleg, who will talk about RBAC, which is just one aspect of Kubernetes security. Did I answer any questions so far? Okay, cool. All right, so Oleg, up to you to do your own presentation. Thank you.
Okay, Damien, thank you for the introduction and for great overview of Kubernetes. It makes my job so much easier because the presentation actually involves a lot of concepts that you explained just so well. So I need to somehow share my presentation, my screen. How do I do that?
Okay. You should have it.
Oh, great. Thank you. Perfect. So I expect that everyone can now see the presentation, and we'll go through several slides talking about Kubernetes RBAC, and we'll do a lot of hands-on activities. The presentation includes a number of slides where you can essentially copy and paste the commands I used so that you can experiment by yourself and play with the Kubernetes cluster you set up. And I suppose we will share the link to the presentation on the meetup page. It's published on SlideShare, so you can see it for yourself. Now, before going to the actual presentation, just a couple of words of introduction. So I'm Oleg Chunikin, CTO at a company called Kubler. And at Kubler, what we are doing, we are building a product called, coincidentally, Kubler as well, which is intended to bring together cloud-native technology stack, which Damian has just explained, based on Kubernetes and enterprise requirements. So, how this vision and idea was born actually. So we were a part of a larger software development company, and at some point we started an initiative to standardize delivery practices for applications that we built for our clients, and very quickly focused on Docker and Kubernetes, as we found that those are absolutely great technologies for application delivery. We built several technologies and solutions around them. Very quickly, we also realized that Kubernetes is, while it's being absolutely great for applications delivery, it's difficult to deliver itself. So who maintains Kubernetes itself? Who deploys it? What do you do if you want to work with multiple clouds, with hybrid environments? How do you manage Kubernetes in different environments? How do you operate it? Collect metrics. So Kubernetes alone is not a full answer, at least for your question, and that's where the vision for Kubler was born, and we built this product over the last 4 years, intended to help IT operations teams to deliver essentially Kubernetes as a service within their organizations. Now, I'm not going to talk about Kubler in this presentation, so the presentation is intended to talk about completely conformant use of RBAC built into Kubernetes. So you can essentially go through that presentation and test it on pretty much any Kubernetes clusters. But I will use Kubler to demonstrate some of the concepts because of a better UI that helps visualize essentially some of those concepts. And without further ado, let's start. So what I'm going to focus on today is Kubernetes RBAC and more widely speaking, Kubernetes access control. So we'll talk about authentication and authorization within Kubernetes, and mainly authentication and authorization for clients working with Kubernetes API server. And you remember the slide Damian showed where Kubernetes architecture includes the API server and multiple clients talking to it. There are internal clients like scheduler, cloud controller, kubelet on every node. There are external clients like users using kubectl, for example, or your CI/CD pipeline, which talks to Kubernetes API to deploy containers into that Kubernetes cluster. And every one of them uses Kubernetes access control, authentication, authorization, and eventually RBAC, which is a subset of authorization within Kubernetes. So I'll go through different ways to authenticate with Kubernetes API server, to build authorization rules, and in the end, we will conclude with several use cases, real-life use cases, and gotchas that you need to keep in mind when you start working with Kubernetes RBAC. So access control, mainly intended to solve the problem of who can do what within the cluster. And to formalize essentially solution to that problem, Kubernetes introduces a number of concepts, and the three main groups of concepts in that area are subjects, operations, and resources. So essentially, subjects is a formalization of the client. So who calls Kubernetes API server? Operation is, operation, what this client wants to do. And resource is an formalization of what we are modifying within a Kubernetes API server or Kubernetes cluster. Now, an important thing to remember about Kubernetes is that essentially whole logic of whole functionality of Kubernetes is built around CRUD, CRUD interface, and REST philosophy and resources exposed through Kubernetes API. Those resources have different types. Most important of them are pods, nodes, config maps, secrets, deployments, and there are numerous other types of resources available within Kubernetes API server. And by creating, modifying, deleting them, you essentially tell Kubernetes cluster what to do. In addition to those basic operations like create, update, delete, there are a few more like list, get, of course, but then watch, where you can subscribe to resource changes and watch updates by other clients, patching resources where you can just provide partial updates, etc., etc. And all those operations on resources by subjects can be managed through Kubernetes access control. So before we go into more specialized topics of authentication and authorization, this slide talks about the anatomy of a Kubernetes API request. So because every request you or client sends to Kubernetes API server has common characteristics. So Kubernetes analyzes, Kubernetes API server analyzes this request, extracts certain attributes, and uses those attributes to decide eventually whether this request should be allowed or denied. And those, this slide summarizes most important attributes of that request. Of course, based on authentication, Kubernetes decides who called the API server. It identifies the user and list of group names in that request. And again, when we are talking about authentication, we'll see how it's done with different authentication methods. But from conceptual standpoint, what's important to remember and know is that user is just a string from Kubernetes standpoint. Users don't have to be managed with Kubernetes. So it can be any string, and role-based access control rules can match any string in the user name. The same is true for groups. And then optionally, there may be a map of arbitrary keys extracted from the request, which may be used for more advanced access control and extensions and various integrations. Then request may be resource or non-resource. So essentially, it's either a REST request to a valid resource within Kubernetes, or it's a request to essentially an HTTP endpoint that does not represent a request, a set of CRUD operations, but rather instead a general HTTP endpoint, like, for example, /version or /meta. So for resource requests, Kubernetes does a little bit more work on analysis. It checks which action it is based on HTTP verb, which namespace it addresses, what type of resource and API group it addresses, what specific resource ID, and optionally a sub-resource if it's a part of the URL. For non-resource request, everything is simple. It's just HTTP request verb and the path of the request. So having all those parameters, now Kubernetes is ready to decide whether the request is allowed or not allowed. Now, a little bit of distraction. So while we are working with Kubernetes cluster, we will, again, as I said, use some hands-on commands. We'll run a few experiments, and tools I'm going to use for that are very basic, very simple. It's curl, if we want to look at how HTTP request responses look like when you work with a Kubernetes API. kubectl, of course, and Damian talked a little bit about that. So that's the main CLI tool for Kubernetes. And then I'll use two auxiliary tools like JQ and YQ. You may find them useful as well. Those are command line, JSON, and YAML visualization and modification utilities, very useful for when you implement advanced scripting with Kubernetes. And here is an example of how you can work with Kubernetes. So let's see. Let's start with kubectl. First of all, when you are working with kubectl, you need to configure kubectl essentially endpoint for Kubernetes and credentials so that kubectl can connect to a Kubernetes cluster. And here I have a file called demo rbug config YAML, which essentially contains credentials and endpoint information for a cluster which I set up through Kubler. So here is a Kubler control plane where several clusters are created in different environments, in Google Cloud, in VMware, in Azure, in AWS, and I will work with this AWS cluster. I created it a little bit earlier. I downloaded this kubeconfig file, which allows any command line tool and Kubernetes client tools work with this cluster. I can check a Kubernetes dashboard of that cluster and see, for example, that it's very simple single node cluster. It has some pods running, so things like that. So let's go back to our console. So this configuration file is everything kubectl needs to talk to our cluster. And I have several ways of letting kubectl know that it should use this kubeconfig file. The first one is just in the command line. So I run kubectl -- kubeconfig, and then I am telling it which kubeconfig it should use. And in this case, I am using get nodes command, and kubectl uses this kubeconfig and shows me that there is one node in this cluster. Another way is setting essentially a environment variable called kubeconfig, coincidentally. And then you don't have to specify the kubeconfig file in the command line. You can just run kubectl get nodes. Because we are going to dig deeper into the protocol and authentication and authorization, a very useful switch for kubectl is verbosity. If you run it with verbosity higher than 1, which is default, I think, in this case, verbosity 8, for example, kubectl will show you a lot of information about request, HTTP request it composed, HTTP response it received, including the response body, which is also maybe useful. And you can see there are request headers, response headers. So you can use those to reproduce this request as a regular curl request. And we can do that just like that. So let's run curl. Similar command. Now you see we are running curl with sending an authorization token to the endpoint on the Kubernetes API server that allows us to get nodes, again, the same as kubectl get nodes command. And we are sending it to JQ utility to format output JSON and less to scroll through it. Here it is. We can see that Kubernetes returned us node list in JSON format with a number of items, in this case, one item, etc., etc. Just as an example again. And let me switch back to my presentation. So if you use verbosity 9, kubectl will print even more information, including essentially the curl command, which you can just copy paste and run in your CLI. I'm just not running it because it also prints out all those secret tokens, etc., etc. Okay, now having talked about tools we are going to use, let's talk about authentication at last. So what authentication mechanisms are available to clients when they are talking to Kubernetes API server? There are several groups. So first of all, it's client certs. So by default, Kubernetes uses TLS HTTPS and client certificates for HTTPS are a valid way to authenticate with Kubernetes API server. Those certificates must be signed by Kubernetes API server CA certificate authority key, which is how Kubernetes API server validates those certificates. And as long as those certificates are valid, the API server will just take a common name from that certificate and will use it as a username. And similarly, it will take organizations from that certificate and will use it as groups. So that's a convention Kubernetes uses. Another way to authenticate with Kubernetes is to provide bearer token. So I'm essentially in an authorization header. And that's what we did here when we sent a curl request. So we sent a authorization bearer token. Oh, yes,
Oleg,
sure.
We have one question from Brunel. Question is, which language the platform is written in?
Kubler, do you mean? Kubler is mainly in Go, plus, well, UI is TypeScript, CSS, HTML, Angular. And Go is very popular language in this new brave cloud native world. So Kubernetes itself is written in Go.
Nice, thanks.
Sure. Thanks for the question. So the next group of authentication methods is bearer token. It's always the same when you send it. So you just send a header with authorization and bearer and then the token. The difference is how you get those tokens and how it's used. So there are several methods of generating those tokens, like bootstrap token, node authentication token, or taking tokens from a static file with which API server, which can be passed to API server as a parameter. All these three types of tokens will not talk about them much, because first two, bootstrap token and node authentication token, are mainly used internally in Kubernetes. So the first one is used by Kubernetes vendors when they deploy Kubernetes clusters. The second one is used by kubelets when they talk to Kubernetes API, and this all is pretty far away from a regular client day-to-day use of Kubernetes API server. Static token file is considered insecure and deprecated, so never use that. And then we are left with two other ways of getting token. It's either service account through Kubernetes API or OIDC token, and we will focus on that a little bit. And then I have to talk about three other ways to authenticate, three other mechanisms for completeness. HTTP basic auth, again, considered insecure, is only possible to configure through static password file, so we won't focus on that much. Auth proxy is mainly used by vendors like Kubler when Kubler, for example, talks to Kubernetes API. It provides its own endpoint to Kubler client. Kubler client works with that endpoint, and Kubler authenticates with Kubernetes and forwards those requests to Kubernetes with the client identification information already. And the same works with many other vendors. So this is called auth proxy, essentially. In this method, Kubernetes trusts the authentication proxy to authenticate the clients. And then the last one is impersonate. That's useful for administrators when they want to check whether they correctly configured credentials or permissions for this or that account. So let's start with the first one, authentication by a client certificate. So I mentioned already that it's just a TLS client certificate authentication, where client has a TLS key. Client creates a CSR request, sends it to someone who can sign it, administrator, for example. Administrator uses Kubernetes API certificate authority key to sign that certificate request and sends back the signed certificate. And now client can use that certificate to talk to API server, and the API server will know who is talking to it. So this is a set of commands that we'll use to see how it works. Again, you can use our presentation to try it at home. Now let me clean our screen and go through this procedure. So first of all, I, as a client, need to have my own private key. So I'll just generate one called user1.key. Here it is, just generated freshly from the own. Now we generate a certificate signing request, and there in this CSR, we specify the common name for the certificate we are asking for and a set of organizations. Those will be interpreted as a username by Kubernetes and as groups. Here it is. Here is our CSR generated. Now, imagine that we are sending it to an administrator, and administrator uses Kubernetes certificate authority key to sign this certificate request and generate a certificate. This command does exactly that. And now we have a certificate which administrator sends back to me as a client. And now I, as a client, can use that certificate and key to authenticate with Kubernetes. How I do that? In this example, I'll use kubectl, and I'll specify the certificate and key in the command line. So here it is, the same get nodes command, but authentication information is the certificate and key. Now let's see what happens. Looks like it did work, a little bit unexpectedly though, because Kubernetes was able to authenticate us as a user one, but it didn't let us to see all the nodes because we just don't have permissions within the cluster. Now, how do we get permissions? I'll talk about specifics of role-based access control a little bit further in the next few slides. For now, let's just show how it looks in practice with user interface, with Kubernetes user interface. I'll just create a role binding called user1 cluster admin, which is global cluster role binding for a role called cluster admin. And this binding is binds this role to user one. And I can have multiple subjects here. I can bind it to groups, as you could see, to service accounts, about which we will talk in a few minutes. But now, in this case, I only want to give this permission to a user one. Okay, saving role binding. Now we have it. And now let's try to repeat the same command. Much better. Now, because we have those permissions, we have full admin permissions in the cluster. Now, cluster lets us see the nodes. Okay, good. And if you have any questions, please use the comment stream. We can get back to this answering these questions, and I will move now to the next authentication method, or it's actually the same authentication method with client certs, different way to acquire that certificate. So what was bad with the previous slide? The previous slide showed that admin actually owns and has this Kubernetes certificate authority key, which is not a good practice. It's a private key information, and the fewer people or entities knows about that, the better. So, which is why Kubernetes has this method of signing certificate requests through the API server itself. So you just need to have initial admin or corresponding permission account in Kubernetes API, and you can ask Kubernetes API server to sign that request. So let's see how it works. So again, as a user, we first generate our own private key and certificate request with a different username. But then there is a difference, and let's see how it goes. So first of all, we are generating our private key, a different file called user2 key. Now we generate a certificate request with a different username, user2. Here it is. Let's see, there are our files. Now we send it back to administrator, and administrator uses its permissions within the cluster to create an object in that cluster of type certificate signing request. And into that object, it puts our CSR base 64 encoded. Let's see how it works. Here we go. We have our CSR created in Kubernetes API, and we can check kubectl get CSR shows all the CSR objects. And now we only have one, user2, just created in pending state. It's in pending state because you may have a workflow which requires a different person approval to actually sign it. And in our case, we are just the same person, and we will issue a command kubectl certificate approve. Here goes. We approved that certificate. Let's see how it looks now. Now it has a condition state approved and issued, which means that this certificate signing request already includes the certificate generated. Let's extract this certificate. I will what I will do for that, I will again run kubectl get CSR, and I will use kubectl options to extract a specific field from that CSR, certificate base 64 encoded, and we'll save it into user2 CRT file. Now this CRT file is sent to the client, and again, now I can use this from the command line, user2 CRT, user2 key to get nodes. Let's try it. And again, now we get the same result. We see that Kubernetes authenticated us as a user2. And again, user2 doesn't have any permissions in that cluster, but that's expected. It's just a fresh user who talks to this Kubernetes cluster. We again can go through the set of those movements with creating cluster role binding, or we can use command line to create a cluster role binding like that. Create kubectl create cluster role binding user2 cluster admin with cluster role cluster admin and the user2. And now as soon as we created this role binding, we can run the same command, and now we are allowed to see nodes again. Okay, so this is what works for certificates. Now let's talk about tokens, and we'll talk about two token types: service accounts and OIDC tokens. For service account tokens, so Kubernetes essentially allows you to create an object in Kubernetes API server that is often used by services to talk to Kubernetes API. So what we can do, we can use kubectl command to create a service account named SA1, and we'll look through that object and we'll see what it holds inside. And then we'll work, we'll show how kubectl can use that token to talk to Kubernetes API server. So first command, kubectl create service account. We see service account is created. Let's see how it looks like. Kubectl get SA or get service account shows us service accounts currently registered in the cluster, and there is a default service account available in every Kubernetes namespace by default. Kubernetes automatically generates it, and then there is this SA1 which we have just created. Let's see what's inside it. We'll ask Kubernetes to print service account content. So it's an object with its metadata section, and the only essential data inside of that service account object is a reference to a secret object called SA token CXRS6, essentially generated by Kubernetes. Let's extract the name of this secret into an environment variable, and let's see what's inside of that secret. Inside of that secret, actually an interesting structure. So it contains data, it contains base 64 encoded API server certificate. it contains a base64 encoded namespace name for that service account, and it contains also the token. And that token can be used by clients, again, just as usual, to authenticate with the cluster. Let's extract this token into an environment variable, and let's use it to, again, try to get nodes. Okay, again, expected result. We sent a token authenticated request to the cluster, and it authenticated us, so it knows that we are calling as a service account in default namespace named SA1. But unfortunately, this service account doesn't have any permissions, and again, we get that message that we cannot get the result. So this is how it works for service account tokens. The last option for token authentication is the most complicated, but at the same time most useful in the real life, probably, at least in the enterprise environment, is authentication via identity provider and OIDC protocol. In this method, an OIDC identity provider is configured for Kubernetes API server as a trusted identity provider. Clients authenticate with this identity provider, and the method of authentication can be different, customizable, depending on the identity provider, how it works, etc. So, for example, an example of identity provider is a Google account API, Google Apps API, the OIDC AWS provides authentication via OIDC, etc., etc. And I apologize, it looks like I have some issues with streaming. Can you see my screen?
Your head. Yeah, we can see your screen.
But yes, so please give me a few seconds. It looks like my laptop, yes, is hanged for a few seconds.
No problems.
Yes, I can hear you, but
right?
again, my screen hangs,
Okay.
and that happened already once today. I'm not sure what's causing it.
Okay, so the slides are online.
Maybe if there are questions, I can talk about. I can talk and answer some of them.
Yeah, I was wondering, how do you handle certificate revocation? Or maybe, how does the admin handle?
That's a good question, actually. So in this simple scheme, it won't work. So as far as I know, there are no certificate revocation objects in Kubernetes API. What may work is actually when you use some kind of external certificate certificate authority that can rotate certificates for users and certificate authority for Kubernetes API servers, for example. So that way you can implement more complex client certificate management schemes. And let me, so while unfortunately this happens, let me talk about other ways of authentication that are mentioned in that slide. As soon as my screen gets back, I can switch back to talking about OIDC authentication because it's probably the most interesting schemes. But two more ways to authenticate includes impersonation. So with impersonation, what happens is that if your current permissions, so you use actually one of the authentication schemes that we talked about already, for example, client certificate or token authentication. Kubernetes authenticates your request, and in that request, you send an impersonation header that includes authentication not credentials, but username and groups of some other user. And if your main user has permissions to impersonate that user, so Kubernetes essentially replaces your security context with that user security context. And I'm sorry. Do you mind if maybe if we interrupt for a second? I'll try to bring my computer back.
Yeah. Sure.
So you might disappear and then come back.
Yeah, I really apologize for
what
happened.
No, that's all right.
So while that is going on, if any of you have any question, feel free to ask the question. It could be on the current presentation or the one I did, or generally on on things in Kubernetes or cloud native environment that you've been maybe trying to understand. You can feel free to talk about that. And if there's no question, if the platform is quiet, I could go back to the presentation I was doing and probably just expand on a little bit on a few things there. So it's up to you. If you have any question, that's fine. Otherwise, maybe I can go back and expand on a few things.
Yeah, I think it's a good idea, Damien. I don't see any questions.
Okay. Do we have, okay. So let's see, what can we do here? I have my cluster here. Okay, let me share my screen. I'm actually sharing. I just need to make it the screen. All right. So we're back to my screen. Let me make it slightly bigger. All right. So clear. All right. So earlier, I was telling you that you have to use kubectl to deploy your objects. And really, Kubernetes works with what we call objects. Everything in Kubernetes is an object. And Kubernetes has so many of those objects. So far, we saw that Oleg had worked with some objects, like he said kubectl-based CSR. So that is an object. CSR is an object. If I have it here, he said I don't have any of that in my default namespace. But I could say get CSR -a, which means on all namespaces. All right. So what does a namespace mean? In Kubernetes, you can divide your cluster into different rooms, so to speak. And a room can be like production environment, or it can be a pre-prod environment. It can be a development environment. So I can say, for example, kubectl create namespace. and NS is namespace. If I want, I can type it full like namespace, or I can just put NS. Usually, you want the shorter form. You can say create namespace deploy, or let's say production. So now it said that the environment has been created. So now that I have this environment, which I said, look at it like a room in a building, in a house. So which means I can keep all my production stuff, I can keep them inside production. And in that way, it makes my life easy. It makes me more organized. And also there are some security features within that. So now that I have this within that environment, if I want to create an object, I can direct that object into the production namespace. So for example, let me see if I can let me try to create this object into that namespace. So I can say kubectl create -f. Let me create the vote one, vote deployment, and then I can say -namespace production. So I'm pointing this object into production environment. Okay. What are you saying? Kubectl create -f. It says the namespace from the provided object vote does not match namespace production. Okay. Okay, you must pass. So I do that. Okay, I think what it's saying is that inside the file itself, so I need to edit that file. I need to edit this file. And you can see that all these are written in YAML. Everything here is written in YAML. So already it's saying that the namespace here is vote. Okay. So I can change that to production. I want to deploy this onto production. Okay, so that will go into that. So let me just make sure that everything is fine. Okay. So now if I do kubectl create -f vote deployment, now the object has been created. If I want to see this object, I have to make sure I do kubectl get ports -n production. Okay, so my object is there running inside the production environment. So the first thing you have to realize or to understand when you're working with Kubernetes is the different environments that you're working with. If I say kubectl get ports and I don't say anything, it takes me to the default namespace. If I want any other namespace, I have to tell it where to go. If I want to see all the namespaces, I can put -a, and that gives me all the namespaces. So when I say -a, I have a lot of Kubernetes objects running on this cluster from all the namespaces. So you can see the namespace, you say this is from default namespace, this is from kube system, this is from OpenEBS, and then we're going to see the one we just created, which is production. You say this is now from production environment, from production namespace. So namespace is how you organize your infrastructure around Kubernetes. Okay, and then if I say kubectl get I can say I want to get all the Kubernetes objects. I can say get API resources. Kubectl. Okay. So if you want to see all your objects, that is what you do. Kubectl API resources. These are all the objects that we have here. I showed you the one that Oleg was working with, which is CSR. Okay. We see it somewhere here on that CSR.
Damien. So we have a couple questions, and also Oleg is ready to join back on. I think we'll have to. So once he's on, I can actually put up those questions.
All right. So now I'm going to hand over back to Oleg. At least you understand what a namespace is. Okay. So, but Oleg, I haven't seen him here to add in yet.
Oh, no. Yeah. So Oleg said he joined. You don't see him?
No, I see. Oh, okay. So it's hidden here, Michael. Yeah. I can add. I can add.
Okay, nice.
great.
Welcome back.
All right. Sorry.
Thank you. And I apologize for this technical difficulties.
No problems. So we have two questions,
Sure.
Oleg and Damien. So I would just put them up here.
Mhm.
So first question is from Maharshi, and he just wanted to have some idea on hybrid cloud like IBM. What are your thoughts? If you guys have worked on it or know something about it, where is it going?
Is it asking specifically with regards to IBM hybrid environment?
Right. Personally, I myself haven't really worked on IBM Cloud. I've worked on AWS and a little bit on Google Cloud.
Mhm.
So I
Well,
personally don't really have much idea what it is and where it's going.
Well, yes, if it's about the roadmap or things like that, then I definitely don't have any idea. But a hybrid cloud is where you have your on-prem environment used with the cloud environment. So in that case, you could have your on-prem deployed with Kubernetes environment, and then you can connect that to the cloud environment. And it depends on whether they have some software they're using, specifically using and managing it. If it's IBM, they have Red Hat. Red Hat was the king of the data center in terms of the Red Hat operating system. And so they have tools, which is OpenShift. They have OpenShift, which is the Red Hat version of Kubernetes. So I would think that because IBM bought Red Hat, they'll be using OpenShift, Kubernetes distribution to help customers that are running OpenShift on-prem to link to the cloud environment where they may be running some other version of Kubernetes in the cloud, like EKS or Google Kubernetes Engine or whatever. So I would think it's going to be OpenShift to something like EKS or OpenShift or something like GCP, but that is kind of general understanding of how things work. I don't know what IBM is doing.
Yeah. So we didn't work much with IBM specifically, IBM hybrid environments. It seems that it's used by some clients, pretty large ones, but still in this ecosystem is relatively niche product. And I think what's important to understand about this ecosystem is especially where and how the tools you are going to use align with your strategy, because there are a lot of products there, and Damian showed this CNCF landscape. It's huge, but each of those products has its own focus and its own agenda, so to say, bias. So, and there are several categories for Kubernetes management products and Kubernetes products. Like there is a category, for example, of vendor managed, cloud managed Kubernetes tools like EKS, AKS, and they are, or GKE. They are absolutely great if your strategy does not include multi-cloud, for example. With multi-cloud future, so to say, you need to think well how you would make those different managed solutions work together, how you would maintain feature parity, for example, in different clouds, etc., etc. So IBM and OpenShift are more in the category of stack-specific solution, I would say. Like OpenShift is better if you are fully on Red Hat stack and don't plan moving or don't plan other types of deployments. And same thing with IBM Kubernetes solution. So in many cases, if you are considering sort of multi-cloud hybrid future or want to stay flexible and independent, it makes sense to at least consider products that are that allow you to integrate those different kinds of large players.
Makes sense. Good. And one other question we have is the secrets best way to keep and store credentials in Kubernetes, or there is a better way for the pods to securely access credentials in Kubernetes?
Well, secrets are specifically designed to store secret data in Kubernetes to a degree that, for example, Kubernetes takes special precautions to not to store secret data on data disks, for example, and only use temporary storage, in-memory storage for them. But yes, there may be a better way of doing that. So, for example, a more secure way may be integrating Kubernetes with Vault and getting those secret data dynamically. But then still there is some point where you need to start some basic place from where you will get your identity information and credentials to at least authenticate in the vault, right? In clouds, you could use instance metadata, but on-prem, if you want to be really secure, you probably have this HSA, I'm not sure, TSA modules, so where you can use special hardware to store identity data. So, but good thing about that. So bad thing about this is that it makes your deployment more complicated and more difficult for developers to reproduce in their environment. On the other hand, good thing about that is that Kubernetes works pretty well with all those tools and allows you to integrate and build a very secure system.
Good. Thanks, Oleg.
Okay, shall we resume, and again, let me switch back to our OIDC excursion. So essentially, the flow looks like that. So client authenticates with OIDC identity provider, gets token based on its credential, their credentials, and uses this token to talk to Kubernetes API server. And the API server is configured and knows the OIDC provider used. So Kubernetes API server uses this configuration to verify that token and then find out who the client is. So let's see how it works. So first of all, it's a little bit different from the previous methods in that you need to configure Kubernetes API server to know about OIDC identity provider. So, and again, different vendors and tools that deploy Kubernetes do it differently. So in Kubler, we just provided this additional configuration information in the cluster specification. So here's for the master, we provided additional parameters for the Kube API server. And those parameters essentially are looking at a key clock identity broker that Kubler uses for authenticating its own user. And in the key clock, we configured a special client for this demo use case that essentially allows us to use this identity provider as an authentication source for the Kubernetes API server. Let's check how it works. So essentially, we'll use curl again to talk to identity provider this time. So we'll call Kubler identity provider or keycloak and see how OIDC responses look like. And let me do the first of these calls, an authentication request.
So which identity provider are you configuring here?
Sorry, yeah, looks like I dropped out because when I fixed my computer, I logged out from my console. Which identity provider? So I'm using Keycloak that runs as a part of Kubler.
Okay.
And yeah,
so it's a service provided by Kubler?
Yes, so essentially Kubler, because it's an enterprise software, an identity provider that is used to create multiple users, manage multiple users, but also integrate with identity management systems in the enterprise is essential. And so that's what we are doing. Let me see. So now I'm back, I think. Here is the console. Let me copy that command and send it to Keycloak. Sorry. Here it is. So what we are doing here, we are running curl with a number of parameters, including client secret for this OIDC and with my username and password. We are using OIDC password grant flow to make it easier to run in the command line. In the real life use case, you would probably use a regular flow, which requires you to use web browser to connect and authenticate with your OIDC provider. But in the end, result will be the same. So your client will get access token, refresh token, and ID token. And let me run essentially the same command, but just save those tokens in environment variables so that I can use it in the next commands. Now I can use, for example, an identity provider call with my token to see what information is stored in this token. It's called introspection endpoint. So you can see that there is a lot of meta information about client, about who is calling, and in this case, DA admin is the user whom I authenticate. So essentially, this is this introspection is what Kubler API server uses to authenticate or to verify that token. Now let's see how it works with kubectl. So we just received this token and we saved it in an environment variable named token. So what I'm going to do, I'm going to put that, those actually tokens, multiple tokens, into my kubeconfig file as a separate set of credentials. And I will create in that config file a record called context. So you may have in your kubeconfig file multiple essentially sets of credentials between which you can switch and use those context. Like here, for example, my initial context, my only context in my kubeconfig file was called AWS demo, and it had all credentials, all permissions in that cluster. And now I created an additional context called DA admin, which contains OIDC token that I just received. And now I set that context as a main one, and now I can try to again run my kubectl get nodes command. And you see, again, very similar result. API server authenticated us. It identified us as an OIDC user taken from this identity provider by name DA admin. And again, it doesn't let us in, doesn't let us do anything there because we just don't have permissions. So the second part of this puzzle is to give that user permissions in that cluster, which can be done through a command line like this. Here it is. We again created another binding with that user. As you can see here, we assign cluster role, cluster admin to this user. And now get nodes work again. So this is majority of the methods you can use to authenticate with a Kubernetes API server. I mentioned already Auth proxy during this blackout, and I talked about impersonation. So let's see how impersonation work as a last exercise with authentication. So I will just run as an admin, having admin permissions. I can impersonate anyone. In particular, for example, I can run kubectl get nodes command as user3 with groups G1, G2. And again, I will see the expected result. Kubernetes accepts me as a user3, but doesn't let me do anything because as a user3, I don't have really any permissions. The same way I can impersonate, for example, not just arbitrary user, but a service account like that. I can say that my user identity string is the specially constructed string that usually corresponds to a service account, and voila, we again are authenticated as this user, this service account. Okay, so this is all about authentication, and let me spend 10 minutes talking about authorization. We already mentioned several concepts there, like roles, role bindings. So on a higher level, roles and role bindings are part of this mechanism for authorization called RBAC, role-based access control. This presentation is named after that, but there are other mechanisms. So let's first quickly scan through those other authorization mechanisms. And the first one is node authorization. So it's used internally. Kubelets are authorized like that. So it just has a special set of permissions that kubelets need in the API server. And API server just allows kubelets to do what they need to do, and this is called a node authorization mechanism. Another mechanism is ABAC. It's deprecated today, but it's what Kubernetes started with. So you essentially can have a static file where you specify this user can do that, this user can do this. Clearly, it's not very secure. And this is why it's deprecated. We won't talk about that much. There is webhook authorization mechanism. It's when you configure API server to ask an external service for authorization decision. And that's used by vendor, by integration, by extensions. So again, so it's probably not something you will deal as a client, as a user of Kubernetes. And two more ways to authorize is always deny and always allow. So those names speak for themselves, mainly used for testing. So you can, for example, bring up a Kubernetes API server instance for your development and specify always allow authorization mechanism so that you don't have to deal with RBAC. And RBAC is the last one. So we talked about webhook. Let's talk about RBAC very quickly. So again, the main objects here for RBAC are, well, subjects of three different types: user, group, and service account, operations, and resources. And you bring them together through roles and cluster role objects. And I already showed you how it looks like. So when we go into a cluster in Kubernetes UI, for example, and go to administration tab, you will see all roles that already exist in those clusters. And majority of them are system roles created by Kubernetes itself and various system software running in that cluster. And similarly, we have a number of role bindings that bind those roles to different subjects, system subjects, like in this case, for example, kubedns autoscaler needs to have permissions to talk to Kubernetes API to scale DNS pod up and down, and this is done through the system permission created automatically. But there are also role bindings that we have just created. So let's see, here it is. There are user 1 and user 2 cluster admin role bindings that we created through UI and through CLI. So what's the difference between roles and cluster roles? Damian talked a little bit about namespaces. So you remember that some objects in Kubernetes are namespaced and only exist in a certain namespace, and other objects are global, so they exist outside of namespaces globally. So roles and cluster roles are exactly like that. So cluster role is a global role that defines permissions to global objects, and role is a namespaced permissions definition object. So with roles, as I said, you have to specify namespace. You cannot specify global resources in namespaced role, and you cannot specify non-resource URLs. In global cluster roles, vice versa. You cannot specify namespace, but you can specify global objects as part of the rules and non-resource URLs. Interestingly, you can still specify namespaced objects as part of cluster roles, and I'll talk about why in the next slides. But before going there, one more useful feature of cluster roles is ability to aggregate them. So your cluster role may be so-called aggregated. It does not include rules then, but instead it includes an aggregation rule, which allows Kubernetes to map that role onto a set of other cluster roles and to essentially provide you with a union of rules found in those cluster roles. So this allows to dynamically essentially manage a set of roles. Like, for example, you can define an aggregated role called my cluster admin, and then any extension that provides a cluster role that gives new permissions to new objects in the Kubernetes API server will automatically be included in your aggregated cluster role. Now, role bindings exist in two sort of flavors. There is role binding, which is namespaced, and cluster role binding, which is global. When you create a role binding can refer either to a namespaced role or global cluster role. And role binding is, of course, as namespaced object, always exists in a specific namespace. So what happens when it refers to a namespaced role? Well, it's clear. So this role binding gives those permissions in this role to corresponding subjects, users, groups, service accounts. But if it points at a cluster role, this is when interesting things start. Role binding will then give permissions to only namespaced objects specified in this cluster role. This helps in that you don't have to create a role for every namespace. You can just have a single global cluster role with a set of namespaced objects. And then by creating a role binding in a certain namespace A, you allow essentially access to those namespaced objects only in that namespace A, which saves essentially a lot of administration efforts. And of course, global cluster role binding is used. It's not namespaced objects. Is used to give permissions to either namespaced objects specified in cluster role across the cluster, or to global objects across the cluster. Now, there are 4 roles built into Kubernetes, automatically created. Cluster admin, which gives you full access to all cluster resources in all namespaces. Admin, which gives full access to only namespaced resources. And then edit role, which is only different from admin in that it gives full access except access to role binding, and local subject access reviews objects. And then the view role which gives read-only object to names, read-only access to namespace resources. Their meaning is essentially follows. Cluster admin gives you full access to cluster. Admin gives you full access to a namespace. Edit gives you full access to namespace except for ability to give access to other people. And view gives you just a read-only access to that namespace. Regularly, normally, when you start working with Kubernetes clusters, this whole system may be quite intimidating, more complicated. So standard recommended approach to how to deal with those roles is to start just with built-in roles. So their semantics is rather relatively clear. So full admin, namespace admin, namespace read-only user, and majority of use cases is covered by that semantics. And after starting with these roles, you can gradually move into defining your own roles for your own more specialized use cases. Now, there are a few gotchas that you need to remember about. So, for example, it doesn't make sense to limit access to within a namespace if you allowed a user to create pods there, which is why it is relatively rare that you see, for example, roles that only give you permissions to run something in the namespace, but not give you permissions to see other types of objects. Mainly because by running a pod, you essentially can map and mount other resources in the namespace, irrespective of your access to those resources. And this, for example, even if you don't have an access to secrets, but you can run a pod. You can run a pod that mounts that secret, and then you can make this pod to send it to you, or you can exec into that pod and see that secret. So in most cases, if you have access within a namespace, it makes sense to have essentially full access within the namespace and limit access to secrets across namespaces only. It's often required for development that you have access to non-namespaced objects. So things like CRD, priority classes, pod security policies need to be created when you deploy a lot of different frameworks, including service meshes, etc., etc. So it's often not enough to just give developers full access to a certain namespace, which is why it makes a lot of sense to have a system like Kubler or Rancher or other cluster management system that allows you to manage easily multiple clusters in different environments. In that case, you can, for example, create a dev cluster for developers, or you can give developers a space where they can create clusters for themselves to test things, to play with things, to break things. It's much more practical than trying to limit and manage their access within the namespace that in a shared cluster. So practical things like that is just the basics. So there are a lot of things that we didn't cover in this presentation, and even with that, it took probably much longer than we planned for. So just a few points to look at if you want to dig deeper into this area. So pod security policies, network policies is a set of objects that allow you to further security in your cluster, limits and quotas, admission controllers, dynamic admission control, and OPA or open policy adapter with dynamic policies. So all those things allow you to greatly to implement very complex use cases that relate to both security and resource management. So this is some reference information on API groups and API objects that we used, and several links that you can use as a starting point to dig deeper. And I think at that, we are done with the presentation. And we had a few of great questions already, but maybe there are more.
All right, thanks so much, Oleg, for the presentation. I wanted to ask, is Kubler, is it open source, or how do people get started?
Oh, great question. So, yeah, you can check on our website, www.kubler.com. There is this Get Started link, nothing mystical, and you can just read through this Getting Started text, and it's just nothing more than running a container with which you will get a demo and installer for full Kubler version. You can check our docs website, where again we have a quick start page. We have a lot of information about installing Kubler in different environments, from the cloud to air-gapped environments. And of course, you can contact us. There is intercom, where we are always happy to quickly answer any questions. To the first part of the question, whether it's open source or not, we use a lot of open source components. We can contribute to open source community. Azure autoscaling functionality in Kubernetes, for example, was contributed by Kubler a couple of years ago. But Kubler itself, Kubler core is not open source. You can use it for free for non-production applications and for evaluation and trial without limitations. But to use it in production, talk to us, and you can either buy a license, or if it's a special circumstances, we can work out an agreement.
Okay, thank you. Michaela, do you have something to say?
Nope, I do not. Oleg did great though.
Okay, no problem.
That was nice. Yeah, just like, sounds like pretty neat product. I'm very much excited to try it out myself.
Oh, great! Thanks. Yep. Yeah, and sorry if it sounded like it was not intended to be a presentation about Kubler per se. So I used it only to visualize some of the concepts we used. Just remember that everything we talked about RBAC can be done exactly in the same way with pretty much any other clusters created through any other product.
Yeah, we do appreciate that. We always like people to, give value to the community, not as a sales pitch, and that is exactly what you did. So it's perfect. We appreciate that. Okay, it doesn't look like there are any more questions. Himansu has to leave because he has to go pick up his kids from the gym, but we thank him for staying, with us for this long. All right, so I cannot see the questions. Let me see if I'm able to see if there's any question. Otherwise, we're going to try and round up in a moment.
Yeah, no, I mean, there weren't any outstanding questions, Damien.
Okay.
And, yeah, I didn't leave yet.
Okay.
But I'm just about to. That was a wonderful presentation. Thank you so much, Oleg and Michaela. That was really nice.
Thank you for having us.
Thank you for having us.
Yep.
All right, guys. Thank you for, again, joining us for this night. I hope you find some value out of it. A lot of the things that Oleg was saying, if they are all over your head, I think you need to get started somewhere. But at some point, once you start using Kubernetes, you are going to start to, look at RBAC for sure, because it's one of the core features. And he's given us a very good start on how to control access to your Kubernetes objects. So all the slides are going to be available. In fact, I already sent you an email with a link. The video is also going to be available, so you can watch it again anytime you want to watch it. So feel free to do that. If you have any question, I'm sure Oleg, as I said, will be happy to answer you. And also feel free to shoot those questions to us as well. So, once again, I want to thank Oleg and Michaela for the great presentation, giving value to our own community over here. And if there's no more question, I hope to see you guys on October 21st, which is going to be our next meetup. So the topics of presentations will be published, and looking forward to seeing you. So once again, thanks, Michaela and Oleg, for the great presentation.
Thank you.
Thank you. Bye.
Okay, bye.